Hello everyone, welcome to the YouTube channel Mission Net Physics Exam. And guys, in today's video I am going to discuss the important concepts of quantum mechanics. As in the previous session of Boom series, I have done the discussion about the most important concepts of mathematical physics, which will be important for the upcoming GATE as well as for CSIR Net Physics exam. I hope you all have watched that session, but if you have not watched that session till now, you can watch it as well, and you can share the sessions or these videos with your friends too, because the videos will be helpful for all the students, those who are preparing for the upcoming GATE or CSIR Net or JEST or any other similar exam. Now let's quickly start the discussion about all these important concepts which I'm going to discuss today in this video. Also, don't forget to tell me about this thing, that how are you finding the session? Is it helpful? Is it helping you to prepare so many important concepts together in very less time? I hope it will. And you can even tell me about this thing in the comments. So let's start the discussion now. Guys, all these are the important concepts which I have mentioned here, based on which we had the questions from 2010 till 2020. Okay, so we are having different questions based on these concepts, and these are like the most expected ones. You can say that you can even have the questions based on these concepts, these topics, these formulae in your upcoming exams as well. Now let's quickly start the discussion. So the first topic which I have considered here, or based on which we have mentioned the formula, that is harmonic oscillator, but not the general one. It's half harmonic oscillator. You can even call it the truncated harmonic oscillator. So if I'm going to talk about the half harmonic oscillator, guys, what is the potential expression you will have for the half harmonic oscillator? So it will have the potential value infinity for some reason, like we have mentioned it here. For x less than equal to 0, the value of the potential will be infinity, okay, or you can call it potential energy. At some of the places the potential will be written, at some of the places potential energy will be written. The most important thing is that just by observing the expression you should get to know about the system. So that is what will matter when you are solving any such type of question. The another thing is, for rest of the reason, which is like for x greater than 0, the value of the potential is what? Half m omega square x square. Okay, now if you are going to have the potential expression given in this manner, you should be able to identify it, that it is half harmonic oscillator or truncated harmonic oscillator. If I'm going to talk about the energy expression, which is going to be for the half harmonic oscillator or truncated harmonic oscillator, which is different than the normal harmonic oscillator energy expression. So what is the energy expression here? This is going to be 2n minus half h cut omega, where n values will start from 1 and they can have, like, n can have the possible values as 1, 2, 3 and so on too. While the another expression of energy for the nth state of half harmonic oscillator will be 2n plus 3 by 2 h cut omega, where the allowed values of n will be 0, 1, 2, 3 and so on too. Clear? Now in the same way you can even have more energy expressions, but you have to check if, let's say, they have given different energy expression and they are asking you which one is correct for the half harmonic oscillator. What you will have to do in that case, you will see that what is the ground state energy value you are getting from any one of the formula, whatever you are going to memorize. Okay, now check from the given options, they will also give you the corresponding n values. So you will have to check which of the option is even giving you same ground state energy, same first excited state energy, same second excited state energy and rest of the states energies as you were getting with the formula you are gonna memorize, and that should be the correct one. You can even memorize any one of them. I have just shown two formulae here to let you know that even if you are gonna work on any one of the formula, you will find the same ground state, first excited state, the second excited state and rest of the states energies. So it's not necessary to memorize more and more, but you should know at least one very well so that you will be confident about it. Next one. Guys, based on the half harmonic oscillator, we are having many questions. Okay, in the previous years in net exam you can get that question, in the GATE even you can find that, so it's very important. Now the next one is related to spin operator. If I'm going to talk about spin operator, here we have mentioned the S positive and S negative values. So these are the values we will have Sx plus iota Sy, and this one S negative will be Sx minus iota Sy. As we all know about the ladder operators, corresponding to angular momentum part, even we are gonna have the L positive and L negative values, which are the raising, and like corresponding to the ladder operators you are having corresponding to each and every operator, these positive and negative values we are generally gonna write. Okay, not each and every, but most of the times. Here, if I'm going to talk about the S positive or S negative, you will have S positive is equal to Sx plus iota Sy, and S negative is equal to Sx minus iota Sy. Now, Sx is equal to what? If you will simplify these two equations, you can add them together. Iota Sy will get cancelled out. You will have 2Sx, and it will be equal to S positive plus S negative, which will give you 1 upon 2 S positive plus S negative, the value of Sx. Okay, in the same way you can even find the value of Sy. Clear? Just by subtracting the equation. In whatever way, it is giving you the answer in simplified form for Sy by subtracting. Okay, or you can just simplify it further. So you will be able to get that point too. Now the next important expression which we generally need to use while solving the questions, that is going to be S positive, S negative plus S negative. S positive is equal to 2S square minus SZ square. If you are the one who is familiar with the eigenvalues related to angular momentum operator, then it will be quite easy for you to consider the questions based on the spin operator too, because the expressions are almost same. Okay, and I will even show you for the angular momentum part what are the expressions we are going to have. Same in what way? So basically, when we talk about L positive, we write Lx plus iota Ly. When we write L negative value, we write Lx minus iota Ly. Even at these terms, you can even put the operator symbol, which will be like this. Okay, so you can put cap on each and every term so that you will easily be able to get, oh, we are considering the operators. Okay, so don't worry about that part. You can put the cap just to show the operator symbol. Now, I was talking about the similarity. So in the same way, when you will write the eigenvalue of, let's say, Sz, okay, it will be Ms h cut, okay, while the Lz eigenvalue is M, okay, h cut. So here we just consider the components corresponding to spin part, and in the angular momentum we just take the normal components corresponding to angular momentum part. So that is the difference. Otherwise the expressions are of similar kind. Now let's talk about the next one. The next is related to perturbation theory part. Okay, perturbation theory is one of the most popular concept and the topic of quantum mechanics, and you can expect like the question based on it in your upcoming exam too. So if you will have any question in which they are asking you to find the first order correction to the ground state energy, what you will have to do in this case, corresponding to the ground state energy, when it will be specified, okay, you just need to write the expression in this manner, and it is mainly the expression for that kind of wave function which is normalized. So nothing you need to consider in the denominator part. You can just write this term, that is psi naught h dash psi naught, where h dash is the perturbed Hamiltonian or just perturbation applied to the system, and that's it. This is going to give you the first order correction to the ground state energy. While if I'm going to talk about the second order correction, this is the formula. Here you have to be extra careful about this thing, that here you are writing the upper level or the excited state wave function, then here the lower one, okay, and in the denominator you are interchanging the energy values. The later on, the next term you are writing is for the higher energy level, okay, so it will be E1 and it is E0. So when you are gonna see, E0 will have less energy in comparison to E1, so E0 minus E1 will be what? Negative value it will give you, while the numerator part is having its square given there, so which means the numerator part either will be positive, or if by chance by integration you are getting it 0 after simplifying the in between the mod term, okay, then it depends, it is 0 or positive, the numerator part only. But after including the denominator part too, you will say the overall value of the second order correction will be either negative or 0. Okay, if numerator is making it 0, that's fine, it can be 0, but from the denominator part, there are great chances that it will be negative. So the statement we are going to have regarding the second order correction to energy, that is, that second order correction to energy will be either 0 or negative. Very important statement. Now let's talk about the next point. The next point is related to the angular momentum operator, or the components. We are going to have different angular momentum components like Lx, Ly, Lz. Based on these components, the commutator bracket expressions are very important. So here we are going to have some of the expressions mentioned like Lx and Ly commutator bracket. When you are going to find, you can see the sequence. It is in the cyclic order, or in continuation you are going to have as a clockwise order, you can say. Okay, so X, then Y, then what will come? Z. When only the angular momentum components are present, in the answer also you will get the angular momentum component. If there will be something else along with angular momentum, then that component or that particular operator will be present in the answer. For example, Lx, Py. So the answer will be iota h cut pz, that is the momentum component. Okay, that is linear momentum. But along with L, which is angular momentum, if you will have momentum component written, the final answer will also have the momentum component in it. Okay, I will even show you that formula later on in this discussion. We will have that formula mentioned too. The next one, and if you are going to change the order, for example, I have mentioned one example here. See, Ly, Lx. So when even anytime we are going to change the order of commutation, okay, that is A with B, B with A. So minus sign difference will come there. So same way, Lx, Ly is giving you iota h cut Lz, Ly, Lx. Even you can see the clockwise sequence I was talking about, it has got changed now. After Y, will you have X? No, it's opposite. So even from that part you can say, okay, negative sign will be there, the minus iota h cut Lz. Or as per the commutator bracket property, A and B commutator bracket will be equal to minus B and A commutator bracket, and that's how even you will get a negative sign here. Clear? Next point. The Ly, Lz commutator bracket again in sequence Y, Z, and then what will come again? X. So iota h cut Lx you will have. Clear? Now in the same way you can change the order, you can even write the commutator bracket for more terms in this manner. Next one, the L square commutator bracket with Lz will be what? It will be 0. Okay, it's very important one. Next, for the 1D box and 2D box, I have mentioned the general energy expressions here because you can expect at least one or even more than one related questions, okay, from this particular concept. So if we are going to talk about the 1D box, then what will be the energy expression for 1D box? That's going to be n square pi square h cut square upon 2ml square, where L is the width of the box you will have, or the length of the box you can say. So this is how the 1D box energy expression you can write. But be extra careful about one point here, that is the allowed n values are 1, 2, 3 and so on too. So they are starting from 1, 0 is not allowed here. You can't take 0 for the 1D box case. For harmonic oscillator it will be allowed, but for the 1D box, 2D box, 3D box it will not be allowed. Clear? Next one. If I'm going to talk about the 2D case and you are going to have the energy expression you are going to write here, it will be what? Nx square pi square h cut square upon 2mlx square plus ny square plus pi square h cut square upon 2mly square. Why I have mentioned the lx square and ly square separately? Because if any time in any question you will have lx and the ly, the length along the x-axis for the box and along the y-axis, if they are different, then also you will get the right answer if you will write this general formula. If they are same, you can take them common, you can simplify. Okay, so it will be quite easy for you in that case too. So I have mentioned the most general expression. Even if the length will be different, you will get the right answer from this expression, okay, along the x and the y axis. Again, the allowed values of nx and ny are starting from 1, 0 is not allowed here for the 2D box as well. In the 3D box case, you will also include the third term containing z. In the same way, you can write that part too, okay. now next one. Next thing is, as we all know that the eigenvalue of Hamiltonian is energy. So we are having the expression which is H psi is equal to what? E psi. So if you are going to operate H on psi, you will get E as the eigenvalue, okay, and you can even simplify it further by putting the operator's value. And here, if you want, for just considering that in quantum mechanics generally we are going to have the operators, okay, so we can just put that cap on the operators wherever we are having the operator present. When you will put the operator's value, you will have the expression minus h square upon 2m delta 2 upon delta x square, and psi will be there. So that's how you are going to have the complete expression, okay, and wherever required you can easily use this expression and get your answer. So this is one of the important expressions you can say here. We have just put the operator's value, but again important. Clear? Now next one, the probability current density based questions have been asked again and again and again in the GATE exam as well as in the CSIR net exam. You can find similar type of questions, so it is equally or very much important too. That is probability current density expression. What is that? The formula we have mentioned here, some wave function will be given to you, and corresponding to that, if you want to find the probability current density, then you can use this formula, which is minus iota h squared upon 2m psi star, the complex conjugate of psi you will have to write here, delta psi minus psi delta psi star. Delta is basically delta upon delta x, or depending on what is that coordinate or the position, or what coordinate is present in that psi expression. Depending on that you will write the delta value, okay. Or also be careful about this thing, that what is the coordinate system they are using. Is it x y z term or r theta, or what has been given in the wave function. So accordingly you can write this expression too. Next one, corresponding to the LZ and L positive, if you want to find the commutator bracket, what it will be? It will be h squared L positive, but for LZ L negative it will be minus h squared L negative. So important expressions, you all should know about it. The next one, again the concept based or the questions based on this concept has been repeated again and again. So what is that? The question is, or the statement or the condition is, let me just show it clearly. I hope it is clear. Just a second. Okay, I think it's fine now. Okay, so if we are going to talk about this one, guys, what is this condition? This is basically for the fermions. How you will write the wave function? Let's have a look at the complete statement so that you will have a clear idea about the condition, and when to consider this wave function you will get to know about that too. So the ground state and the first excited state wave function for a 1D infinite potential well, if you know, these are psi 1 and psi 2, for example, okay, any system we have taken here. So it is the 1D box, 1D infinite potential well we are talking about, and its ground and the first excited states wave function we have mentioned here, okay. When two spin up electrons, now fermions have been introduced, there are two spin up electrons we are having, clear, are placed in this potential, then the space part of the ground state wave function of the system will be what? Okay, so that's what you need to find. It will be 1 upon root 2 psi 1 x1 psi 2 x2 minus psi 1 x2 minus psi 2 x1. For the spin up electrons or electrons having the same spin, you are going to write the wave function in this manner, where x1 and x2 are going to denote the position of the electrons, the two electrons. So this is something important, and based on this expression or this condition we had many questions in the previous years, so focus on this one a little more, okay. Actually all the concepts are important which I am telling you in this video today, so try to focus or try to revise them even after the after you will complete this video. You are gonna watch it completely, do the revision, try to make a good command on all these concepts. It will be helpful for all of you. Clear? Now next one, if I'm going to talk about the next expression, which is corresponding to we have mentioned for the harmonic oscillator. So in general, if we are going to have the potential energy given in this way, which is half m omega square x square, and we want to write the nth state energy in this case, what will happen? It will be n plus half h squared omega where n values are gonna start from 0. Okay, this time for the harmonic oscillator, n values can start from 0, and the nth state energy in general will be n plus half ℏ omega. Next point, if we want to write the energy for the 3D case, and here again I have mentioned it for the generalized case, okay, which means I am considering that omegas are also different. That means angular frequency is also different corresponding to different directions. So I am showing them with omega x, omega y and omega z. So what we are going to get here, half m omega x square, half m omega y square, half m omega z square. Even if omega x, omega y, omega z are same, that will be known as isotropic harmonic oscillator. When I have taken them different, it is an isotropic harmonic oscillator. So isotropic will be a particular case which we can consider, which we can get after considering the expression as an isotropic case. So if you will make them equal, omega x, omega y, omega z, you will get the isotropic case. Okay. And the expression of energy in this case will be what? Nx plus half ℏ omega, nx plus half ℏ omega y. Okay, corresponding to x part you will write omega x, corresponding to y part you will write the omega y value. If they are different or if they are same, you can observe that, but it's okay. Even if you are considering this as the generalized expression, you will not make mistake. Okay, nz plus half ℏ omega z. So this is how you can write the energy expression. Now let's talk about the next one, that is the angular momentum operator. If you are going to operate the L operator on the wave function, that is psi NLM. Okay, psi, which is corresponding to the state in which the NLM values, like we have just taken a notation here for the principal quantum number, orbital quantum number and the magnetic quantum number. So when you will operate L on this particular state, you will get the eigenvalue as root L into L plus 1 ℏ psi NLM. Okay, next one, the LZ, if you are gonna consider, it's gonna be psi NLM equal to what? mℏ psi NLM. This is how you will get the eigenvalue for the LZ operator too. Next, if I'm going to talk about the L positive and L negative values, like we have already observed the S positive and S negative values, so how we will write the L positive and L negative values? So in the same way, Lx plus iota Ly for L positive, Lx minus iota Ly for L negative. In the same way, you can see here for the L positive, L negative plus L negative, L positive, the value you are going to get finally in terms of L and Lz. Why in terms of L and Lz? Because you can see, you know about their eigenvalues. You know when you will operate them on a particular state, what value you will get. That's why we prefer to write them in terms of L and Lz. Okay. Next one, Pauli matrices, we need them in so many different questions, like anywhere they can be present. In the perturbation based questions, in the eigenvalue based questions, they are asking you to find the energy, okay, or anything. So the Pauli matrices can be required in any such type of question. So you all need to know the Pauli matrices expression for sigma x, sigma y, sigma z. Okay, you can observe one phenomena here corresponding to all these different type of Pauli matrices. What is that? That is the determinant of all these Pauli matrices will be equal to what? It will be -1. So if you will observe for this or for this, the determinant will be -1. Okay, next point. Now as I was telling you about this thing, that anytime if you will find the commutator bracket of angular momentum operator with any other operator, like the momentum operator is here, only the linear momentum, so what you will get in the final answer, that another operator you will get. Okay, so one example I have shown here, and since it is in the cyclic order x, y, then z will come, so positive, even, okay, because it is in sequence, and that's how you're gonna have the answer. Now spin, if in any question the spin is involved and they have given us the information regarding the spin, that spin is 3/2, spin is 1/2, spin is 5/2, like that. So to know about this thing, that in one particular state how many such particles can exist, you will firstly have to check the degeneracy. How to check the degeneracy to know about this thing, that in one state how many particles will be existing? With the formula 2s plus 1, where s will be the spin you will put. Okay, next one, related to raising and lowering operators, related to the harmonic oscillator part, you are gonna have the A and A dagger expressions, as I have mentioned them here. They are very important. You all should know about these expressions too. Then A into A dagger part, okay, the multiplication of A and A dagger when you will consider in terms of Hamiltonian, how you will get the expression. that will be h upon h cut omega plus half, and here a dagger A will be h upon h cut omega minus half. Next point, if I am going to consider the commutator bracket of A with A dagger, it will be equal to 1. The commutator bracket of A with H, it will be equal to A h cut omega. The commutator bracket of A dagger with H, it will be minus A dagger h cut omega. The commutator bracket of H with A dagger A, that will be 0. Now, these are some of the very important expressions related to commutator bracket related to raising and the lowering operators. So, if possible, you should try to memorize these expressions because they will help you to solve the questions quickly in less time just by putting the expression, just by applying that formula and get your answer. But they are very much important too. Next one, the operator A dagger A is also known as the number operator or the preserving operator. Why? Because if you operate it on some state, it gives you the state back. That means it's not making any changes in that particular state. So what it will give you? It will just give you n and n, where n is the state on which you have operated it. So this is how it will give you the answer, where n is its eigenvalue. Okay, when you have operated this operator on the particular state, you got this eigenvalue. Next point, if I'm going to talk about A operator, which is the lowering operator, and A dagger is what? The raising operator. So A, when you will operate on nth state, you will get root n minus 1. While when you are operating A dagger on the nth state, you will get root n plus 1 n plus 1. Okay, next one. Here you can see the lowering operator is lowering the state. The nth state was there, but now it has become n minus 1. Raising operator is increasing or raising the state. Here the state was n, but now it has become n plus 1. Okay, and the eigenvalues or this value which you are getting, you can even have a look at that part. Also guys, one more thing for the harmonic oscillator, for any particular state, if you want to know about the expectation value of position or momentum, you can directly say corresponding to any state, these values will be 0. Next point, related to total scattering cross section. The formula for the total scattering cross section, we represent it with sigma, and the formula is 4 pi upon k square summation L is equal to 0 to L plus 1 sine delta naught. What is k here? K is the wave vector. L corresponding to the state, you will have the L value given to you. Okay, or you will consider it accordingly. Delta naught is the phase shift. Okay, this is how you can put all the values which will be given to you in the question, or some information regarding these values will be given to you in the question. By putting them, you will be able to get your final answer. Next point, the degeneracy formula for the 3D isotropic harmonic oscillator. What is that? That is n plus 1 into n plus 2 upon 2. Clear? For whatever state you want to find the degeneracy for the 3D isotropic quantum harmonic oscillator, you can use this formula and you can get your final answer. Next one, if any time you are going to have the wave function at time t is equal to 0 given to you, and you want to find the wave function at later time t, what you will have to do in that case, you will just have to multiply that wave function as per the different states which will be present there with the expression e to the power minus iota en t upon h cut. En, you will keep on replacing it as per the state present at a particular term, and you will keep on getting that, like the expression at any later time t. Okay, this is how you can find it by multiplying the sine t is equal to 0 wave function which will be given to you at time t is equal to 0. If you will multiply that wave function with this term, okay, then you will be able to get the wave function at any later time t. The last point is, for harmonic oscillator, if any time you need to find the expectation value of x square corresponding to any state which will be mentioned in the question, then directly you can use the formula, that is h cut upon 2m omega 2n plus 1. Okay, this is how you will be able to find it. Now guys, this was the discussion about the most important and very much expected questions which you are gonna have for your upcoming exams. Okay, so you can get or you can expect those questions from these concepts, these formulae, these topics which we have included here in this session today. So it was quite important discussion. Okay, and you can even share the video with your friends. Now let me just provide you some information regarding the Unacademy Iconic and Unacademy Plus subscription. So guys, as you must, you may be familiar with the Unacademy Plus subscription, that if you will take the Unacademy Plus subscription, you will be able to attend the more regular live classes of well-structured and the well-planned courses by the top educators we are having on Unacademy Plus for your upcoming CSIR NET and the GATE physics exams preparation. Even if somebody is going to prepare for the NET exam or the GATE exam, their preparation for rest of the exams will get done. Okay, so with the guidance of the top educators, you can prepare very well. You can get to know about the right strategy to prepare for the exam. You can take your preparation to the next level too. And whenever you are going to take the subscription, whether the Unacademy Plus or Unacademy Iconic subscription, you can even use and apply the referral code, which is Anjali Arora, as mentioned here. No space in between, spelling should be same. That's how you need to write it and apply it and get the 10% discount in the total Unacademy Plus subscription amount. Clear? Now, if you will take the Iconic subscription, what are the benefits you will get? Let me just tell you about them. So you will get a personal coach allotted to you who will be there for you 24/7. That means at any point of time, you can ask about any of your doubts, okay, to the personal coach, and there will be customized study plan. You will get unlimited practice, structured schedule. Then you are gonna have preparatory study material, personalized doubt clearing, booster sessions and workshops. All the benefits which I have told you, you will get after taking the Plus subscription or Unacademy Plus subscription. They will even be included in the Iconic subscription. SOP and interview preparation you will be able to do after taking the Iconic subscription. And even guys, whenever you are going to take the subscription, you can use and apply the referral code, which is Anjali Arora, as mentioned here. No space in between, spelling should be same. That's how you need to write it and apply it. One more thing, that when you will take the Plus subscription, you will even be able to attend the mock test, okay, and even the practice sessions which have been mentioned here. The doubt clearing sessions will be there in each and every course. So that's how you'll be able to prepare very well with the Plus courses as well, okay, or Plus subscription as well. Or it is going to be completely your choice whether you want to take Unacademy Plus or Iconic subscription, or if you think, yeah, you want the guidance by the top educators, then you can go for it and you can take the subscription too. Clear? So whenever you are going to take the subscription, you can use and apply the referral code as well, which is Anjali Arora, as mentioned here. No space in between, spelling should be same. That's how you need to write it and apply it. Okay, so guys, I hope that this video was helpful for all of you. Even you got to know about the important concepts and everything which we have covered in this session today. So thank you so much everyone for joining and this session or for watching this video till the end. And please let me know in the comments, how did you find this video? Was it helpful, not helpful? You want more such videos? Or what are the topics related to which you want me to upload the videos in upcoming days? So you can even keep on telling me about that thing in the comments. I will try to just provide you that topic related video too, as well as if you will have any doubt, I will try to clear that too. And keep on sharing the videos with your friends as well. Thank you so much everyone for watching this video till the end. Thank you.